This video will help you complete Lab Assignment 3, Hypothesis Testing with Independent Samples. So for this first study, we're going to be doing an independent samples t-test. We are going to be comparing scores on an academic achievement test between children who attended preschool for 6 months and children who did not attend preschool for 6 months. So first thing I want to show you is how to conduct an independent samples t-test in Microsoft Excel. We actually did this already for the last lab when we tricked Excel into doing a single sample t-test, but I want to show it to you again and also discuss the difference between equality of variances and inequality of variances. So let's start there. First, I want to copy my data, so I can left click that little four-cornered arrow that pops up and then click Control and C at the same time to copy. You can also right click and then just select copy. And then I'll go into Microsoft Excel and paste it. So if I go back and I look at my data, you'll see that we have 12 different people in each group, and we have 2 different groups. So we're going to have a total of 13 rows and 2 columns. So when I go into Excel, 2 columns, and then all the way down to the 13th row, hit Control V. You can also right click and then do the paste, whichever one you like to do. And just because I want my data to look nice, I'm going to double click right here. Oh, it didn't work, so I'm just going to drag it so that preschool is all in one line. There we go. Okay, so let's do the t-test. Now before we do, I want to just check to see if I have equal or unequal variances. So if you go to the data analysis by clicking the data tab here and then go to data analysis. Now if you don't have this, you'll want to watch the video from the last lab that shows you how to install the data analysis tab. But if I click here, you'll see that we have 2 different options for the 2 sample t-test. One is assuming equal variances and one is not assuming equal variances, or in other words, assuming unequal variances. Well, remember, these samples are meant to represent the population, and anytime that you have 2 different samples, you're going to have differences in the statistics for them, just due to sampling error. So we don't expect to see perfectly equal variances between these 2 groups. But the rule of thumb is that if you see a variance between these 2 groups, and one is 4 times larger than the other, then we can't assume equal variances, and we would do this t-test here. But if we calculate the variances, and we can assume equal variances because the 2 variances from the sample aren't one of them isn't 4 times larger than the other, then we can use this here. That gets at the homogeneity of variance assumption that's discussed in your textbook, but that we didn't have time to cover in class. So just to be really safe, I'm going to go ahead and calculate my variance here. And you won't have to do this for your lab. I'm just showing you how to rationalize which t-test you need to use. So I'm just going to select equal var, and I want variance for the sample. So I'll double click that, and I'll highlight this data and hit enter. There's my variance for that one. And then my sample variance for this sample. Double click, and then highlight and hit enter. And looking at this variance isn't 4 times less than this variance. So they're close enough for me to assume that I do have equality of variances. So I'm confident that I can use this t-test assuming equal variances. So I'll click on that right there. So I'm going to select my variable 1 range right here. And then my variable 2 range will be my second variable. So again, I just clicked on this, highlighted the data, including my label, and then clicked here and highlighted this data, including my label for that. You can go ahead and leave this hypothesized mean difference blank. Just make sure that you check the box that says labels so Excel knows that the first row that you selected were for the labels for your variables. And then I'm going to have my output go to a new worksheet, and I'm going to name this t-test preschool, just to keep track of what I'm doing. So let's click OK. Before I start to interpret this, let's go ahead and format the numbers. So you just click and highlight all these numbers. Right click, go to Format Cells, select Number, and then tell it you want to go out 3 decimal places. And then I can do my double click at the double-sided arrow in between each column to automatically make the width match the content in each cell for that column. Okay, so now you can copy this. So just highlight it, hit Control Copy, go to your lab assignment where it says paste the output below. And I'm going to paste special just so that it's easier to work with. So I'm going to click this arrow below paste, go to paste special, and then I'm going to select picture enhanced meta file. I'm going to shrink this just a little bit. There we go. I want this to be on another page, so I'm just going to click right here and then hit Control and Enter to automatically break the page. I'm going to make some space there too. Okay, so now this is asking, did children who participated in the preschool program have significantly higher scores on the academic achievement test compared to children who did not attend preschool? So I'll make this a little bigger just so we can talk about it. Okay, so how do you know? Based on the p-value and based on the critical value in the Microsoft Excel output. So our alpha level is 0.05, and we're doing a one-tailed test because we're thinking in terms of directionality that the preschool group is going to be significantly higher on the academic achievement test than the no preschool group. So we know that the p-value and the critical value that we're going to be working with are those for the one-tailed test, so these guys right here. So just like before in the last lab, this tells you what your mean is for each group. To get the standard deviation, which you'll need to do your APA-style conclusion, you'll take the square root of your variances. This tells you that you have 12 people in the preschool group and 12 in the no preschool group. This is your pooled variance, so that SP squared that we've been calculating. This tells you your degrees of freedom, so 11 plus 11, right? N1 minus 1 plus N2 minus 1 is 22. This would be the T statistic that you calculate in step 3. And this tells you that the observed difference in academic achievement scores between the preschool and the no preschool group is 4.055 times larger than what you would expect to see just due to random sampling error. And then our one-tailed p-value is 0.000. It's less than our alpha level of 0.05. So this means that, and let's go back to our Excel sheet because we know this one-tailed p-value tells us that there is a, let's click on it, 0.000263 all the way out chance of type 1 error. So remember, when you report this in APA style, you would write p less than 0.001 just to show that you know that there is no, it's not that there is no chance of type 1 error, that's smaller than 0.001, and within rounding, it's less than 0.001. So let's go back to our lab. All right, so that's your p-value. We're only willing to accept a 5% chance of type 1 error. This is less than that, so just based on that, we can reject the null hypothesis because p is less than 0.05. Now, we can also reject the null hypothesis according to the critical value. So we are expecting that our critical value is going to be positive because we are expecting an increase, so we have to keep that in mind, higher scores. And if we plotted this out, this critical value would be at 1.717. This would exceed that, the actual t statistic or the t observed. So it would also tell you you should reject the null hypothesis and say that, yeah, children who participated in the preschool program did have significantly higher scores on the academic achievement test compared to children who did not. So a couple of things about APA style. So remember, you need to take the square root of your variance to report the standard deviation. And here are a couple ways to do your notation in APA style. So for instance, for r squared, if you want to type r, and then you click on this little button up here, the superscript button, r squared, and then a space, and then click it again so that your equals in the superscript, and then you can put the r squared that you calculate using these values in there. Just a quick note about eta squared. So you can find the eta squared if you go to Insert, Symbol, More Symbols. And if you go to the Greek, where am I? There we go, Greek and Coptic. And you click down. There's your eta, so you could select that. And then the same process for getting the little squared thing. So remember, eta squared is the effect size for your ANOVA that you'll be reporting. So just make sure that you're using the correct symbols so that it is actually in APA style when you report that. Okay, so let's go on to the next one. So this is looking at 3 different conditions of meditation. One is an audio meditation created by a researcher. Another one is where a parent uses a pamphlet to guide their child through meditation. And then this one involves no meditation. I think they just watch a video about a field trip going to the zoo. So this would be like the control condition. And what we're looking at are scores on the Vanderbilt Assessment Scale, which measures attention deficit hyperactivity disorder symptoms. And the hypothesis is really that we're hoping that this audio meditation really decreases the symptomology of ADHD. Or in general, just meditation is better than no meditation. But remember, with the ANOVA, we can't make directional hypotheses. We can just say, okay, is one of these groups at least significantly different from another group? So that's why, for extra credit, you can do a post hoc analysis after we do the ANOVA in Excel. The post hoc analysis in Excel is a nightmare, so I'm not going to have you do that. You can do it by hand for extra credit. So let's conduct a one-way analysis of variance. One way because we only have one independent variable. That's the only thing that we covered. To see if there are significant differences in ADHD symptomology, so what these scores represent for the dependent variable among the 3 groups, and then we'll paste the output in here. So let's go ahead and copy this. So I'm going to left click, Control C, and I have in each group, I have 10 people. So there's 30 people total, 10 in each group. So I'm going to have 11 rows, because we have to add one for our labels, and 3 columns in Excel. So let's go ahead and go to a blank sheet. 3 columns, 11 rows, Control V, and I've pasted it in. And I just want to make sure I've got all of my data there. So 0.3, 2.1, 3 was my last row. Okay, looking good. And I'm going to go ahead and click and drag so that these fit. Okay, let's do the analysis of variance in Excel. So we'll click on Data Analysis, make sure the Data tab is selected, Data Analysis, and then we will do the ANOVA single factor. Factor is just another word for independent variable. We only have one independent variable, meditation, and we've got those 3 levels of it. So let's go ahead and click for the single factor. Now, with Excel, you just highlight the whole entire thing, all your data, including the labels for each group. Make sure that grouped by columns is selected, and then make sure that you check labels in first row. And then we're going to create another worksheet called ANOVA Meditation, just so that we know what our tab represents down here, and then click OK. So I'm going to do my clicking so that all the content fits. All right. Okay, so now we have our output for our ANOVA. Let's go ahead and format our numbers here. So highlight all the data, right click, go to Format Cells, Number, 3 decimals. Then we'll do the same thing here. Right click, Format Cells, Number, 3 decimal places, and click OK. Now we want to copy and paste this whole entire output, because if you look at your lab, it tells you to paste the output for the descriptive statistics, so this stuff right here, so your N, your sum of X, your mean, your variance, and for the ANOVA analysis, so your source table. So I highlight all that, hit Control C, then go into my Word document, and I will paste special. So click the arrow below paste. Make sure that you're in the Home tab. Arrow below paste, paste special. Picture enhanced meta file, and there we go. So again, these are your descriptive statistics. That's what's referred to, right here, your descriptive statistics, and then the ANOVA, that's the source table. Now this should look very familiar to you, at least this part here. This gives you all the values that I've been giving you all along in class for step 3. So this is your p-value. The interpretation is the same as it always has been. It's the probability of type 1 error. But in looking at this, you can see that, yeah, it says 0.000, but in reality, it's not no percent chance of type 1 error. It's just less than 0.001. So that's how you would report it in APA style. And then here's your F crit. So remember, the distribution for F is a positive skew, and you can't have any negative values. So you don't even really need to draw this out to figure it out if you've been drawing the others out to figure it out to see if it's significant. Because we know that our obtained F is way larger than the F crit, so we can reject the null hypothesis according to both of these. So your p-value is less than your alpha level, which in this case is 0.05. So there's less than a 5% chance of type 1 error, so we're really confident in rejecting the null hypothesis that that's the correct decision. And then your F observed is larger than your F crit here. So that's how you know that there's at least one significant difference between these groups. So that's where you would want to go for your extra credit to do the Tukey's HSC post hoc analysis to see, okay, is there a significant difference between these two, or between these two, or between these two, or between all of them? You'll find that out if you go and do number 10. So with the conclusion in APA style, there's a great example in your book, and it includes an APA style table. Now, the two different versions of the book have two different table styles, and neither one of them actually adheres to APA style. So I'm going to show you how to make an APA style table to summarize your descriptive statistics for an analysis of variance. So the first thing that we want to do is we want to have a table that includes, let's see, so insert our table. I think we're going to need about 6 rows. We can always add more if we need to. So 6, and then we are going to need 3 different columns, I think, to start with. All right. So we want to create a table that summarizes our sample size, our mean, and our standard deviation for each of the different groups. So let's go ahead and start here, where you will label Table 1. And if you see the conclusion in your book, it'll make a reference to, results or descriptive statistics are presented in Table 1 at the first part of this. You can include that sentence if you want or not. As long as you have the table, I'm okay with it. So Table 1, and then you go a space down, and then you hit Control-I to do italics, or you can go to the Home tab and just hit I up here. And let's go ahead and label this table Descriptive Statistics for Meditation Groups. Now, for this first part, just worry about getting the information into the table, and then I'll show you how to make it pretty and perfect in APA style. All right. So now you want to go down to the next row here and type in VAS scores. So that's our dependent variable, what we measured, what these scores are, the VAS, the ADHD symptomology test, basically. Okay, VAS scores. Then your next row, right here, you want to put meditation group. So this will be the column that has all the different groups listed. And we have 3 different groups. We have the audio meditation, the parent meditation, and then the no meditation groups. And those come from these 3 different groups that we have up here. Now, for each group, we want to report the sample size. So Control-I, and then N. Your sample statistics, your statistical notation are always italicized. And then over here, we're going to report the mean and standard deviation. So Control-I again, or you can click I for italics. Capital M for the sample mean, then hit Control-I again to make your first parenthesis. Then Control-I again because you're going to put SD in here for standard deviation. And then Control-I again to make your last bracket or your parentheses not italics. Okay. So now we need to go up to this table to get the values to put into this table. So if we go up here, we're looking for our sample sizes and then our means and standard deviations. Let's start with all the sample sizes. Well, there's 10 people in each group. That's what the count tells you. Or you could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people in each group. So 10, 10, and 10. Let's do our means next for each group. So that comes from, here are averages. So 1.065 for the audio group, 1.825 for the parent meditation group, and then 2.580 for the no meditation group. 580. Now to get our standard deviations, we have to take the square root of our variances. So the square root of 0.289, square root, 0.53, rounding to the thousandths place, 0.538, so then in parentheses, 0.538, and the standard deviation for parent meditation is going to be 0.368, square root of that, so 0.368, square root, 0.607, and then finally, the standard deviation for the no meditation group, 0.188. What's the square root of that? 0.434. So just looking at the mean and standard deviation, we can already see that the no meditation group had higher scores on the VAS, or more ADHD symptoms. The audio meditation group had the lowest mean, so the least amount of ADHD symptoms. And then the parent meditation is somewhere in between. And the parent meditation group had the least consistent scores, higher standard deviation, and the no meditation group had the most consistent scores, consistently high in this case. Okay, so now we have all the information that we need in our table. Now we need to put it into APA style. So the first thing that I want to do is I want to go ahead and highlight these guys, the whole table, select no spacing to get rid of all the extra spaces. Then I am going to go to my layout. I'm going to highlight this one row, and I'm basically just going to make, it doesn't work. So I have to go to the layout tab to make the width of each column make sense for the content, to actually fit the content, not be too huge. So I highlight this first column, go up to the Layout tab under Table Tools, and I can adjust the width right here. So I can click and shrink it down. Then I'm going to do the same thing for these two. I'm going to do both of these at the same time because it's nice to have these be the same width. Just looks nicer. So I'm going to shrink it to right about there. And then I want all of this to just be on one row. I don't want to have it all squished into this first column here. So if I highlight all this and then go to Merge Cells, we're still in the Layout tab for Table Tools, and I merge my cells, and then I want to include a space after Table 1. The next formatting thing that we need to do is we need to make this all on one row here. We want to keep this column by itself, but we want to merge these two cells because the VAS scores are what we have the N and the mean and the standard deviation for both of these columns. So we want this to be above both columns. So just highlight that, click Merge Cells. Then we want to center all this. So we can highlight all of this, and then still under the Layout tab, click on this middle, Align Center. So we're going to align it center, horizontal, and vertically, and do that. We're almost done. We almost have an APA style table. Now all we need to worry about is taking care of these different lines here. We want to create the borders in accordance with APA style. So you can click the top left up here, that little four-arrowed thing that's gray. Click it. Then go to the Design tab And let's get rid of all of the borders. So you just click this arrow next to borders and go to no borders. I'm going to manually add them in accordance with APA style. So if I go to the side of my table and I click right here and scroll down, I can do it that way because I want to add some borders above and below this. Or you can just do this. Another handy thing to know about doing this to make it easier to see where are your rows and columns now that you've got rid of these lines is when you click on this, if you go to Layout and select View Grid Lines, you can actually see where those grid lines are even though they aren't really part of the table anymore. So I'm going to do that just to make this a little easier. So go back to the Design tab. You want to highlight these two rows and create a bottom border and create a top border there. Then you want to select this VAS scores and create a bottom border there. And then you want to select this bottom row and create a bottom border there. Let's go ahead and get rid of these grid lines. So highlight the table, then go to Layout, click View Grid Lines again, and it gets rid of them. And you have a perfect, beautiful table that is in APA style. If you were trying to publish these findings, this is the kind of table that the publishers would be looking for to describe your descriptive statistics for this analysis of variance. So that is all that I'm going to show you for today's lab. Because this is extra credit, I'm not going to show you how to do it. I'm not going to give you the answers here. But you've learned how to do this in class, and it's also in the textbook, and you have all the information that you need from your outputs and your data to do this Tukey post hoc analysis to see which pairs of these groups are significant, and then just make sure that you explain those in plain English. All right, guys, I hope this video was useful for you, and I hope that you start this lab before our review session so that you can ask me specific questions in class before it's due.